Hey kids, welcome to section 3.2, solving quadratic equations by graphing. Today we're going to learn how to solve quadratic equations by graphing and how to estimate solutions of quadratic equations by graphing. So the first thing we're going to talk about is what are quadratic equations. So quadratic equations are quadratic functions that are set equal to a value. And if we're looking for solutions, we're looking for the place where it's crossing the x-axis. So what we're going to do is we're going to take a look at standard form, which remember is ax squared plus bx plus c. And as long as a doesn't equal 0, and as long as a, b, and c are nice numbers, are integers, so no fractions, no decimals, then I'm in something called standard form. Once you're in standard form, we're going to be looking for solutions. These solutions of quadratic equations are also called roots. And one of the ways that you can find roots is by finding the zeros. And the zero is also known as the x-intercept. So kids in math, we're annoying. We have multiple words to say the same exact thing. But if you're looking for a solution to a quadratic function, then you're looking for something called a root, but the root is also known as a zero, and you know it as an x-intercept. So if you look at the picture here, these two values, these two order pairs right here, are called the solutions of the quadratic because they are the place where it crosses the x-axis. So we've got roots, we've got zeros, we've got intercepts, and they're all solutions. So let's take a look at how we can find these solutions. Now, a lot of times life is perfect and you can find the exact roots, but if exact roots are not possible, you might have to be asked to estimate. So let's first visualize what does it look like when we are graphing quadratic equations. Well, our quadratic equation could sit right on top of the x-axis, crossing it only one time, therefore giving you one real solution. You can have a quadratic that crosses the x-axis 2 times, giving you 2 real solutions. Or you can have a quadratic that never touches the x-axis, giving you no real solution. Now, these actual solutions might be nice numbers or they might not be nice numbers. And so we're going to take a look at how you can estimate them either from a table or from a picture. Now, if you look at a table of values, so let's say we were to graph this, we would have a graph and the picture would be above the x-axis, above the x-axis, below the x-axis, below the x-axis, above the x-axis. And anytime you have a positive changing to a negative or a negative changing to a positive, you're crossing the x-axis, that's got a 0. So to see what that makes more sense, let's look at a picture to be able to see what these are. So the directions say to solve each equation by graphing. So we're solving it, meaning you're going to tell me x equals in the end. If exact roots cannot be found, state the consecutive integers between which the roots are located. All right, let's first solve it and then we'll worry about the second sentence. So in order to solve it, let's graph it. Well, I already taught you how to graph. Let's use the calculator to graph. All right, so we're going to go to y equals, and we're going to type in the function. Notice it's equal to 0, so I can type in the function x squared plus 2x minus 15. And then let's hit graph. And remember, we're trying to find the place where it crosses the x-axis. Looks like it's crossing right here and right here. So we have 2 times. Now it's kind of hard to tell what those numbers are, so go to the table. And now look for some repeating stuff. Oh, look at this. Where's the numbers repeating? Oh, they get bigger, get bigger, get bigger. Oh, there's where they all start to repeat in the y's. Now, our job, though, is to figure out what the solutions are. Solutions are where they cross the x-axis. So notice I have one solution here at 3, and I should have another solution at, oh, there it is, -5. So you just have to go through in your table and you're looking for which x values have y's of 0. So negative 5, 1, 2, 3, 4, 5. And then negative or positive 3 is my other one. 1, 2, 3. So it's going through at x equals negative 5 and it's going through at x equals 3. Now you just need some more information in order to graph. So take a look. It looks like negative 1, negative 16 is your vertex because my numbers start repeating, which is like way far down. So we're just going to put it down here. So to find the solutions by graphing, I'm looking for where does it cross the x-axis, and I have to physically say what x equals. All right, letter B. Notice this time, first thing I notice is that the graph is going to be facing downwards because the a value is negative 1. Also make sure that it equals 0. If it does, you're good to go to your calculator. So we're going to type in negative x squared plus 8x minus 12 and then hit graph and hope you get a downward facing parabola. All right, we do. Notice it crosses 2 times in the x-axis, so we're going to have 2x equals solutions. Let's go to our table to get some graph. They were over on the right-hand side, so positive. Again, you're looking for where are your y values 0. So I found one at 2 and one at 6. So I have x equals 2 and x equals 6. Doesn't matter the order you write them in. And then 1, 2, 3, 4, 5, 6 is my other one. Now I need a vertex, so I need to figure out another point. Remember, it's opening upward or downwards. Looks like it's maybe somewhere here at 4. So go back to your table and take a look. Oh, yep, it does look like 4, 4 is going to be our vertex. So 2, 4, 2, 4. Once you got you need at least 3 dots in order to be able to graph a parabola nicely. Where it crosses the x-axis, those are your roots. Or solutions, or zeros, or x-intercepts, you choose. All right, next slide. Example 2, solve each system each equation by graphing. If exact roots can't be found, state the consecutive integers. Well, we found exact roots, so. All right, if we look at letter A, notice this side, there's no one side equals 0. So we need to make one side equal 0 so we can enter it into our calculator. So we need to do some shuffling from side to side. We need to bring the negative 8x over to the other side. We need to bring the 11 over. So we're going to have x squared, bring the 8x over, so plus 8x. And then we're going to add 11 to both sides, so that's going to give me plus 16 equals 0. Once I get an equals 0, I can jump over here to my calculator. X squared plus 8x plus 16. Hit graph. It's going to touch only one time over here on the negative side. So I'm going to have 1x equals. And then let's go to the table, find in the negatives, oh, there it is, negative 4 comma 0. So it's at negative 4, 1, 2, 3, 4. Now I need 2 more points to graph it, so I'm just going to use the points that are on my table right now. So negative 5 comma 1 and negative 3 comma 1. There's my picture. It's crossing one time at x equals negative 4. That's my solution. That means that I should be able to take this negative 4, plug it into the equation for x, and I should get 0 in the end. If I don't, I did it wrong. If I do, I did it right. All right, take a look at letter B. Looks like I need to make one side 0. Now it's your choice which way you move stuff. I'm going to make this negative x squared be positive by moving it over, which means I'm going to subtract the 12 to both sides. So I'm going to get x squared minus 12x plus 36, and that equals 0. So let's go to our calculator. Let's do x squared minus 12x plus 36 and hit graph. It crosses one time over here on the positive x-axis, so we're going to say x equals, go to our table, look around in the positive side. Oh, there it is, 6, 0. 1, 2, 3, 4, 5, 6. So my solution is x equals 6. And if I want to graph it, I can use 5, 1, and 7, 1. 5, 1, and 7, 1. Connect your dots. There you go. All right, next one. Same directions. All right, so we need one side 0. I'm going to bring the negative x squared and the 2x to the right. So that's going to give me x squared minus 2x plus 4 equals 0. I'm going to go to my calculator. X squared minus 2x plus 4 and hit graph. And oh, look at that. It opens upward, but it never crosses the x-axis. That means there is no real solution. Now, you might be thinking, what's this whole real thing here? Well, in the latter half of the chapter, you are going to learn about imaginary solutions. And so for right now, no real solution. You still have to show that there's no real solution by graphing the function. So go to your table, find some values that are nice to graph. It looks like 1, 3 is good, and then 0, 4, and 2, 4. So visually showing that the graph is not crossing the x-axis, but is opening upwards above it. All right, take a look at letter B. Solve one side for 0. I'm going to bring everything over to the left-hand side. So I have x squared plus 4x plus 6 equals 0. So I'm going to go to my calculator. X squared plus 4x plus 6. And hit graph. Up again, this one is opening upwards and it's above the x-axis, so there is no real solution. So let's go to our table and try to find some ordered pairs. It was over on the left-hand side of the x-axis, or of the origin. So let's see, negative 2, 2. And then it looks like negative 1, 3. And negative 3, 3. No real solution. Okay, so we've been able to either state exact roots or say that there aren't any. Now let's talk about the second sentence. If exact roots cannot be found, state the consecutive integers between which the roots are located. So first, make sure one side is 0. It is. So we're going to type this into our calculator. X squared minus 6x plus 4. And then I'm going to graph it. Check and see. It is crossing 2 times. So we're going to have 2x equals down here. So let's go to our graph, or our table. And let's try to find those zeros. Notice it was over here in the positive side. So when we look in the table, we're going to be looking in the positive side. But weird thing is, I don't see any zeros. And look what's happening in the y values. The y values are getting smaller and smaller and then bigger and bigger. So at no time, though, are the y values 0. Now, the other thing you should notice is take a look between 0, 4 and 1, negative 1. Notice that at 0, it's above the x-axis, And at 1, it's below the x-axis. So what had to happen between? It had to hit the x-axis. So that means there's going to be a 0 in between these two spots. There's also going to be a 0 down here between 5 and 6, because at 5 it was -1, at 6 it was +1. So this one is not going to be a nice x equals answer. This is going to be state the consecutive integers. And consecutive integers are numbers that are right next to each other when you count. So since I don't have nice, beautiful roots, I'm just going to graph the picture using my table. So graph enough of the picture that you can see where it crosses the x-axis. So specifically 0, 4, and then we have a 1, -1, and 2, -4, 2, 3, 4, and then 3, -5, 4, -4, 5, -1, and then 6 goes up at 4. So you need to be able to graph the parabola so that you can see where it crosses the x-axis. And then once you connect the graph or the order pairs, then you can say that the first 0 is going to be between, well, it's right here. At 0, it was above. At 1, it was below. So it's kind of deceiving, but somewhere in between 0 and 1, we hit the x-axis. And then if you keep looking, 1, 2, 3, 4, between 5 and 6, we also hit the x-axis. So you're not going to be able to say exactly what the roots are, but you're going to be able to state the consecutive integers between which the roots are located. So I don't know exactly what it is. It could be 0.7. It could be 5.3. Later in the chapter, you're going to be able to tell me what it is, but for right now, we're just estimating what the solution is. All right, letter B. First thing I notice is one side is 0, but I don't really like this negative in front. So I'm going to change that to a positive, which is totally allowed. But then again, let's just leave it and see what happens. So, all right, so negative x squared. I guess you sometimes have to get used to working with numbers that you don't really like fractions. Nobody likes fractions. They always get rid of them right away. All right, so here's our graph. Looks like it's crossing 2 times, so we can remind ourselves that we're going to have 2. It looks like one's in the positive and one's in the negative. So let's go to the table and look for some zeros. I don't see any zeros, and I see numbers that are continuously getting bigger and stuff. So it looks like we're going to have another betweener. So take a look. There's a negative changing to a positive right up there. And then if you look here, you got a positive changing to a negative. So we definitely have some estimating. Let's just graph whatever we can. So let's see, -3, -2, and -2, 4, and -1, 8, 0, 10, 1, 10, 2, 8, and then we got to show that it's crossing the x-axis, so we got to keep going a little bit more. 3, 4, it's metric at this point, and then 4, -2. Yep. Okay, so now we can connect the dots in as artistically round as possible. Oh, that was a little off. Let's change that. Let's fix that one because we want to make it look better. Yeah. Okay. So we have one between, let's see, -1, -2, and -3. So between, and I always put the smaller one first, -3 and -2. And then the other side, 1, 2, 3, and 4. Between 3 and 4. All right. So those are your estimating roots. All right, let's do some word problems. these word problems are going to test your understanding of how things are launched in the air. Remember, anytime you throw something in the air, it's always going to be in a parabolic fashion. You may think that you're throwing something super straight right in front of you in a complete nice straight line, but it's going to arch in some way. So here's our first example. An apple is launched directly upward at 64 feet per second from a platform 80 feet high. The equation for this apple's height at time t after launch is h of t equals, we got this negative 16t squared plus 64t plus 80. Hint, graph on a calculator. Okay, so let's type this into our calculator. Negative 16. Now notice that it says t squared in the problem, but we're still going to use an x. And even though there's a capital T on your calculator, don't worry about that. We're always just going to think of this as an x button. Maybe when you're in higher up math classes in college, you may use the other values there, but not for us. Okay, so if we type the equation in and we graph it, we're not going to be able to see a ton of it. It's going to go up and then it's going to come back down again, but we're not going to be able to see the peak. Now we can zoom out, so we can try to see if we zoom out, we can see it. Still can't really see it, so you can zoom out again, but it gets even worse and you really can't see it. So if you zoom 6, that's your standard. It resets it back to the original window. All right, let's read what we're trying to actually do. Find the maximum height of the apple. So the maximum height is up here at the very top of the graph, and so that's the y part of the vertex. So we need to find the y part of the vertex. Well, in order to find the y part of the vertex, you got to find the x part first, and the x part is negative b over 2a. So we need to take a look here. Let's see, our a is negative 16, our b is 64, and our c is 80. So we're going to do negative 64 over 2 times a negative 16. So that's negative 64 over negative 32, that's 2. Remember, you're not done. You got to take that 2 and you got to substitute it into the original problem for x, or in this case t. So we're going to find y equals negative 16 times a 2 squared plus 64 times 2 plus 80, and we're going to get 144 feet. So that means the apple is going to reach a maximum height of 144 feet in the air. That's pretty tall. Part B wants to know how many seconds will it take for the apple to reach the maximum height. Well, how long it takes to reach the maximum height is the x part of the vertex. How long? Because remember, time is your x value and your height is your y value. So you have time and you have height. So guess what? You already did it, and the answer was 2, so we can say 2 seconds. Part C, how long is the apple in the air before it hits the ground? Well, if it hits the ground, that means it's going to have a height of 0. And if the height is 0, then that's a solution. That's an x-intercept. So all we have to do is go to our graph and figure out what this value is. Now, I don't really care about the one on the left because negative time doesn't exist. And so technically this part of the graph doesn't really exist in the real world. So I'm only looking for this one on the right. Well, let's go to our table and see if we can find a y value of 0. And look, we can. If our x is 5, we get a y value of 0. That means that after 5 seconds, the apple is going to hit the ground. So the order pair for that, where it hits the ground right here, was 5, 0. And so if it's 0 height above the ground, it was at 5 seconds. All right, let's do another example. This one's about golfing. A golfer hits a ball from an elevated tee box 200 feet above the fairway. The ball's height h above the fairway is modeled by the function h of t equals, where t is the time in seconds after it is hit. Notice, kids, that the 200 that they talked about in the problem is the same 200 that's in the equation. That's on purpose. And then this 28 is your initial velocity. Sometimes they'll tell it to you, sometimes they'll just put it in the equation. And that negative 16 is your gravity. So all of these numbers mean something. They don't just randomly happen. How long will it take the ball to reach the fairway? So the fairway is another way of saying the ball hits the ground. And if the ball hits the ground, the height is 0. Well, we need to go to our calculator and we need to type this equation in. So negative 16, we're going to type in x squared plus 28x plus 200. And then we're going to hit graph. We're going to take a look at the picture. We're not going to care about the left one because that's time doesn't exist over there. We're looking over here at this right one. Now it looks like it's not crossing at a beautiful spot. So let's go into the graph or the table and take a look. It looks like between 4 and 5, at 4 seconds I was at 56, at 5 seconds I was at negative 60. That means that somewhere between 4 and 5 seconds we hit the ground. Between 4 and 5 seconds. I can't spell between 4 and 5 seconds. So we couldn't actually say explicitly what the amount of time was, but it was between 4 and 5 seconds. How long will it take for the ball to reach its maximum height? How long is time? That's the x part of your vertex. So I need to do negative b over 2a in order to find that. So if I say my a is negative 16, my b is 28, and my c is 200, then when I do negative b, I do negative 28 over 2 times a negative 16, so that's a negative 28 over negative 32. That gives me 0.875 seconds. Wow, it takes less than a second for that golf ball to reach its maximum height, but it takes between 4 and 5 seconds for it to actually come down. Interesting. Okay, letter C. There is a 250-foot concrete wall between the golfer and the hole of victory. Will the ball clear the wall? So I'm looking for hitting the ball, and there's a wall in the way, and I want to know, will my ball clear the wall? Well, if I can figure out what the maximum is of my vertex, then I can see if I'll hit it or not. So I already know that the x part of my vertex was negative 8.75 or negative 0.875. I need to find the y part of my vertex to see what the highest part is of my golf ball's path, and then I'll be able to see if it clears the wall. So let's plug it in. Negative 16 times 0.875 squared plus 28 times 0.875 plus 200. If I type this into my calculator, hit enter, I'm going to get 212.25 meters. That means that the ball's path is going to reach a maximum height of 212 meters. Well, I think I meant this to be 250 meter tall. So, yeah, I apologize. So if the maximum height of the parabolic path is only 212, it's not going to be able to get over a 250 meter concrete wall. So the answer is no. The maximum is less than the wall's height. All right, kids, that is the end of section 3.2. If you have any questions, please let me know. And as always, keep calm and keep trucking.